methods available for carrying out EIA. And last day and today half day you have properly seen how a satellite image can be downloaded from various platforms, as well as how land use land cover analysis can be carried out on a given satellite image. At the same time, you have also seen that how we can generate LULC for our region of interest. Okay, you have seen some other things also like accuracy assessment and types of classes to be classified in a particular land use land cover analysis. Now, since the theme of this course is the application of remote sensing in GIS in EIA, from now on, what all lectures will be there? It will be oriented towards how remote sensing, whether in part or whether in full, is used to prepare a EIA report. Okay, be it air, be it water, be it noise, or any other thing. Okay, so I'll share my PPT and I will be sharing with you one of our case studies which we have done for Indakara Kayankulam block. And please keep in mind that I am recording it, but since it is a strategic type of EIA, this recordings and all you should keep it up to you. That ethics and integrity I leave it to you. I'll be sharing with you, of course, but those values and types of thing which we have done, you should keep it up to you only. Okay, so I'll share my slides and then we'll start. Okay, so I hope my slides are visible. Any one of you?
Yes, sir.
Yes, sir.
Yes, sir.
Great, great, great. So now, first I will show you uh, some uh, some applications of remote sensing GIS in this particular session, and then after a break, I will take a case study in which significant use of land use land cover has been done to find out the impact of something on something. Okay, that you will see in which specifically remote sensing is used. Okay, but in this case, I will be showing you the interface of remote sensing with various components of EIA. Okay, so the title of my talk will be EIA of minerals and mining, individual and cluster of mines and other case studies. So actually, what all case study I'll be showing you will be for an area related to minerals and mining. But you rest assured that principles, methods, and tools will be same for any type of EIA project. Since I have experience in minerals and mining, I'll be sharing minerals and mining with you. Okay, so first one, just give me a minute. Sorry for the inconvenience. Okay, so I will be showing you a case study on minerals and mining. First, I would like to give you a brief of one area. It is called Nindakara Kayankulam Belt. Okay, you can see here Nindakara Kayankulam Belt. It is situated in Kollam district of Kerala, and this whole belt is blessed with heavy mineral sand, in which such heavy minerals are there, which has varied application in defense as well as paint industry, as well as different kind of coatings and all. So I'll just give you a brief of this. This Chowra Beach deposit covers a length of 22.54 kilometers with a width of 221 meters. And this whole stretch is a good source of ilmenite, rutile, zircon, and sillimanite, which are atomic minerals and finds wide application in various industries. So, as per one survey by ISB, IBS, Indian Bureau of Mines, IBM, a total sand available here is 1400 million tons. Okay, which accounts to around 127 million tons of heavy minerals, of which 80 million tons alone is ilmenite. Okay, ilmenite is a very prominent heavy mineral which has various applications in defense as well as paint industry as well as different kind of material science engineering. Okay, so this whole block was divided in eight number of blocks. This one single block was divided in 8 blocks, and it was given to two different companies. First company is central government, that is IREL. So all the even number of blocks are allotted to them. Okay. And second company is KMML, Kerala Minerals and Metals Limited, which is a state government company. And odd number of mining these blocks are given to them. Okay. Now, first thing you should understand this I am able to represent because I know little bit about the mapping in remote sensing. So first application here itself, that how I will represent it. Okay, of course I am doing it in Google Earth, but this is also a part of mapping only. Okay, so I hope up to this point the task is clear to you. And now I'll be I'll be showing you some of the other part of this land use land cover. Oh, sorry, some of the other part of remote sensing GIS for 5 different mine lists. Okay, 5 different mine lists. So you can see here, this is block 1. This belongs to Kerala Minerals and Metals Limited. Then block 2 EE. E means Eastern Extension. Okay. Then block 3, block 4, and again block 4 EE, Eastern Extension of block 4 EE. Okay, so this all are what you are seeing. These are mine leases. Okay, in this only mining will be carried out, open cast mining of heavy minerals, and heavy minerals will be extracted from that. Okay. So first thing, a comprehensive map. Then second thing, I have plot all the mine leases here. Okay, these all are my ROIs. ROI 1, ROI 2, ROI 3, what Anish has taught you in previous classes. Okay, and this circle is a 10-kilometer radius buffer circle. Okay, someone was asking me the day before that how much area we need to include. So based on the quantum of work, we have decided 10 kilometers. Okay, we have decided 10 kilometers. So this itself has been plotted using remote sensing and GIS. And instead of Google Earth, this map can be superimposed on any satellite image. So now you understand this is the first application itself. The base maps and other relevant details which are required to carry out EIA. Now first step will be the preparation of base map. Now what does it indicates base? Base means which you take something as a basis for carrying out other works, right? It is the basis of all things. So first step number 1 while doing EIA, in which remote sensing and GIS will come into picture, will be the preparation of base maps. Now, when you are doing the base map, what all things you need to do? Okay, first, since you will be doing your work in a proper way, and you may need to publish that work to the international journals and any other reporting. So what you will do is that first you will prepare a country map in which you will show that this is India and this is the state of Kerala. In that state of Kerala, you need to show the district, 1 point, and then one more important point. Okay, so first thing you will show where the India is. Then in that India state of Kerala, in that Kerala where that mine is situated. And when you are showing that particular portion, first you have to show the mine list. In my case, it is IREL block 2. Okay, and then you have to show the connecting roads. So always remember that in a base map, basic features will be there like roads, okay, places, and nearby water bodies. Okay, at least this much should always be there so that when I'm carrying out an EIA, I'll be able to know how to go to the site, what is the connectivity to that, what are the places, huh? And what are the nearby water bodies to it. That thing you have to keep in mind. And then I have to give the basic details of it, like the area under consideration is 62.204 hectare. Anish has already showed you how to calculate areas. This is Smiley is 62.204 hectare. Then out of that, how much available for mining 8 hectare, and this total mineable reserve is this much, and inland mining this much, beach washing this much, because there will be intertidal zone. So all these things based on the base map, you have to write there itself. Of course, field survey will also be required for these quantities, but this base map can be prepared on desk itself. Okay. Then similarly, this is a base map for 2EE, which is area of 67 hectare. I showed you already. Then this is for block 4. Block 4 for IRL India Limited, in which the area and other mineable quantities are different. This is for block 4E, Eastern Extension. Here you can see here that we have plotted the map here, and we have shown other features also, like from inside if any water body is going, right? Any other mine lease block nearby. Here it is KML block 3. C is which side, inland water body which side, all those things you see. And again, indexing is there. Okay, India, Kerala, and this one. These maps you can very well make if you practice just for, let's say, 1 week or 2 weeks. Okay, these shape files are also available for free from various website. And if you wish to obtain shapefiles of all these things, you can refer to DEVA GIS. DEVA GIS. You can note down DEVA GIS. There you can get all the administrative boundaries for free, even up to the taluk level. Okay. So this is base map. And then the same one. This is same one, block for E. But here I want to show the minor details also. So I have superimposed these 4 points, and I'm showing this area in my buffer zone. You can see here at 10 kilometers. So here I can see if I'm carrying out an EIA, what all features will form the part of this region. Okay, this is NK block 4E, 10 kilometer buffer area. Okay, and this is block 3, KMML block 3. So basically, I have shown you examples of base map for block 2, 2E, block 4, 4E, 4E again just for final refinement, and block 3. Okay, these are all different kind of representation of map. Like here you can see India and Kerala have given small, but these things are given more so that I can show from Trivandrum International Airport how far it is, right? From other C district, C interface, how far it is. So like that, you should understand this is the way only it is to be given. Okay, we have mentioned also district Kollam, nearest railway station Karunagapalli, nearest airport Trivandrum International Airport. Accessibility can be reached via National Highway 66 and like that. Nearest weather station Alapura 68. So when you are preparing maps, all these things you can keep this in mind what I am showing you here. Okay, be it block 2E, 4, 4E, and 3. Okay, so now I hope base map is clear and the various ideas of preparing base map is also clear to you. Yeah, of course, this is also an example. This is block 3, and we have prepared base map of block 3 also, in which this is block 3, mine list. This whole side is C. This is a landward side in on which places as well as roads are given. Okay, and you can see here this is a 10 kilometer buffer boundary. 10 kilometer buffer boundary. This is Arabian Sea and this is KML block 3. Okay, so up to base map, any doubt?
No, sir.
Okay, so this is the first step. Is the first step when you will just give the project description and its base map, like how it is situated and all. Now let's come to air environment. Okay, so please recall my first day when many of you were asking that whether we'll be seeing any demo or not. So I told you that day very clearly that air itself is a big subject, and this course objective is to give you details from remote sensing in GIS, which you will use to give input to all other environmental components like air, water, coastal erosion and all. So same way I'll be describing you this. So when you are working in air environment, what you will need is that you have to give your base map as input and not in JPG and all. You have to give the vector files, what you will be working in QGIS. Okay, vector files. Then you will require your land use land cover map. Okay, and then sometimes you can also use satellite data to prepare the baseline of air quality, and then you can predict the baseline data. That when you are exploring properly USGS and Copernicus, what Anish had showed you first day, the interface of USGS. On USGS, there are satellite for air pollution also. But since it is not the purview of this course, so that we are not showing. But with this knowledge, you can very well do it. Okay. So now, first thing what I'll be doing. You can see here, I have given my input of base maps, base map and LULC map. Okay, I have given my input to this. So here you can see that one LULC map is there. Of course, it is not in that other format. It's a Google Earth format only, but you can give yours also and my base map. And then what I have done is that I have digitized a road on that. You can see this is a road on which I am drawing the line. This is a road. And then what I have done is that I have run my FDM model. FDM means fugitive dispersion model. Okay, fugitive dispersion model. This is not part of the course, but you can do it separately. So here I know my land use land cover. I know my base map, and I also know the meteorological parameter, which I also showed you first day when we were discussing about the air environment. Like we should know the wind speed and wind direction, relative humidity, right? Temperature, rainfall, all those things. So all those things will be inputted in the air quality modeling software, and then this output will be there. Now, what you have to do is that once you have that output, you have to superimpose it on your study area. Then only you will be able to understand how your pollutant will disperse in the environment. And that dispersion you can only plot using GIS. So here you can see that just near the road, the color is dark. So it will be 98 microgram per meter cube. Then as far as I'm going away from the road, values are decreasing. It is coming. I'm not able to properly see it. Anyway, other image will see. The value is decreasing from the center. Okay, so this is for block 2. And what you have to do is that once you know this dispersion profile, you have to see some points in which you have done the monitoring. Like in our case, we have done near plant, then we have done near the Kotta Kulangara junction. One junction is there. We have done near one guest house. And we know what is the present concentration of particulate matter. And after this modeling exercise, we have superimposed the same on that, and we have seen the color from the color bar, and we have seen after when the mining is carried out, how much will be the load. So like that, we have worked out this is without mining. This is with mining. Okay, that's what I was saying you first day also, that in AIA, many times we have to do prediction in terms of with and without. Okay, and then we have to compare it with the standard. That also I showed you in the steps that you have to compare it with the standard. Similarly, we have done one work for 2E. 2E was slightly different. So there are two dispersion profiles. You can see here, this is the 2E minus, and again, we have plotted the color bar based on the FDM output, and we have superimposed it on our land use land cover. Again, we have seen what was the present PM10 concentration. And if mining has been carried out, what will be the concentration of PM10 on various points? This point I'll be only able to see when I'm superimposing it in GIS. This you have to keep in mind. Okay. Unless I plot it on GIS, I'll not be able to see what will be the concentration of that pollutant on particular point. Excuse me. Okay. This is for 2E. And then sorry. Now, once you know that this is my pollution profile, and so I have to do something for it. So what you will do is that you will try to give the mitigation measures. Okay, you will try to give the mitigation measures. Now, this pollution is occurring when the mined material is has been transported using trucks. Okay, when the mined material has been transported using trucks. But what if you are not using trucks? So what you will do is that you will again prepare a base map. Okay, this is the answer to one of the participants, those who are asking that whether we can prepare management plan using GIS. I remember first day someone asked in the chat box. So I said that in case studies we'll be seeing. This is the answer to that, and so many things we'll be seeing now. So you can see here, first I have superimposed my 2E boundary on the cadastral map of the area. From that, one water body is going out, is passing by. So instead of taking the material through this road, then going to a national highway, then again coming back, what we suggested this, can't we use any barge here itself? Right, barge means that bigger trucks, no, not bigger trucks, bigger uh, water vessels which carry truck itself. Okay, so mining will be carried out. It will come to a barge and see directly road is there, and then it can take anywhere. Okay, this is a mineral separation plant. You can see here. This dotted line is the separation plant. So from whatever you are mining, you have to take it to that point. So instead of taking a big road, you will just use a barge and you can do it. So you can see here, I was only able to give this management plan because I'm aware of remote sensing GIS, one thing. Second thing, because of GIS, I'm able to see the picture from helicopter viewpoint, means from a top position. Then only I am able to do any plus minus or any other modalities which is required in that. Okay. And then again, here also we have seen what is the present PM10 concentration and what will be the PM10 concentration during the mining activity. Okay, similar, this is the output for block 4, same one. And in this case, we have given alternate things like this is a particular mine list. Okay, this is a particular mine list. And here a lot of mining works are going on and pollution also will increase, especially particulate matter. So in this case, what mitigation measure we have given is that we have proposed an alternate route through National Waterway 3. Okay, IRL plant is somewhere here. You can see one yellow dot. IRL MS plant. MS means mineral separation. Now, if I take it again through road, you know that on the road, first traffic will also increase, other thing will also increase. But what we have done is that we have given one proposal that why can't it be taken here from National Waterway 3, NW3, which is a water body. Okay, and this we have plotted in GIS. Second one we have given is that we have given one existing truck route and proposed route diversion. Here you can see this is the mine list and here is the plant. So from mine list to plant, I have to bring my material. So I am taking it here from that route. Okay, I am making a transportation route. All right. What I can do is that I can give alternate plan. So what we have done is that this red line is empty truck route and black line is loaded truck route. Means when the truck is full, it will go from this road, and anyway national highway will be common for all because it is wide road, and it will come from this point and go to plant. But when it is empty, it will not go from the same road. Before touching the highway, it will go from here so that they will not face each other. And from here, it will go from here. So empty will go from this side and loaded will go from this side. So like that, I could do some route optimization. You are getting my point. Using GIS, I could do some route optimization. And needless to say, when you are working in GIS, you can very well measure the length also of this road. Okay, you can very well say, okay, length of the loaded truck is 10 kilometer, length of the empty truck is 11 kilometers, so not much difference. Okay, not much difference in the management plan. Like that, you can manage. So in this case also we have tried to work out what is the present concentration and what is the concentration after the mining activity has been started, and we have compared it with the existing standards. Okay, this is again a plot of block 4E, and in this case also we have given similar kind of management and mitigation plan. This was block 4, which is a smaller area, This is block 4E, which is not a smaller area. Okay, this is bigger one. E means eastern extension. So first we have to show always the existing truck route from where the material being taken, and then we have to suggest other things. So here what we have suggested is that because it is a big plant, so here we have suggested to transport the things through pipeline. Okay, and we have also given one plan that how that pipeline will be taken here, because already there was one pipeline of water, and when you mine the sand will be in a slurry form. Always keep in mind, because it is on the beach. So whenever you are mining the sand, it will be in the slurry form. And that slurry, if you use pumps and pipe without any truck and tipper load, it can be directly reached here. And when you use electricity, there is zero emission in electricity. Okay, and that's a separate issue that in thermal power plant there will be a lot of emission. But in this particular case, when you are using the electricity, emissions will be less. Okay, so this is alternate transport through pipeline. And then in this case also, again, we have given the similar kind of thing, that from where loaded truck will go and from where empty truck will go. And again, this was for pipeline. This is for different route, empty and loaded. And this is what if I use this national waterway itself. Okay, what if I use national waterway itself? Can instead of come to this? Okay, so alternate route map through TS canal. TS canal means Thiruvananthapuram Shoranur canal. These are two places in Kerala on which the canal is named. Okay, and similarly, this is air quality modeling for block 3. And similar thing we have done, land use land cover, base map, fugitive dispersion model, superimposition of my relevant points, and then preparation of mitigation measures and management plans. Similar, no change in this one. This case also. Okay, now here what we can do is that this you should understand that when I'm showing you examples of IREL, their plant is situated at one place and their mining lease is at one place, at least 6 to 7 kilometer far aerial distance. Okay, but same is not the case with KMML. In case of KMML, their separation plant is situated within the mine lease itself. So there what you will do, if you come from this side, you will not be able to do mining. So here we are given an alternate route for transport from mining lease to MSP. Like this you can see here, 2.172 kilometer, then one barge and mineral separation plant. Okay, so what I was trying to convey to you is that when you are using remote sensing GIS, there will not be a single solution. Okay, you have to keep in mind, no single solution. You have to work out the alternatives. Okay, you have to work out the alternatives, and based on those alternatives only, you will be able to come out at a particular picture. Now, I want you to recall my first lecture on EIJ, in which chapter number 5 is analysis of alternative, if you remember correctly. There only you will see all the alternative. If not this, then what? Okay, if not that also, then what? Like that, and you have to arrive at a feasible solution. Okay. Okay, so I hope up to this point is clear to you. Up to base map and air, anyone would like to ask anything? Any doubt in base map and air? No? Okay, then we'll go ahead. Now we will come to the water environment. So before starting water environment, let me drink some water. Okay, so now you have seen that first we have to give an overall picture of the area, then we have to prepare the base map, Then we have seen the air environment. Now we will see something in the water environment. So when you are starting the water environment, you should recall first the sources of water. Like what are the surface water sources and what are the groundwater sources. Okay, surface water and groundwater. And then first you have to design the sampling network. Okay, first you have to design the sampling network. So now here you can see is that I am doing this study for block 2. Okay, block 2. This is block 2. Now I open my GIS and I am trying to see from where I should take the sample. So naturally, when I'm taking a sample, my sample should be representative, plus it should describe or it should represent whole of the Mindleys at once. Okay. So what I have done first, I'll take the sample from the first point. Then after some time one more, after some time one more, then one more, and like that. So you can see that it is fully distributed. Okay. You can see that it is fully distributed. It is not like from one place or itself I'm taking everything and no representation of other areas. Okay, so first thing what you have to do is that you have to decide the sampling locations using GIS. You have to design a tentative location, and with that tentative location, you have to go on site. Slight changes may be there, no problem in that. But with that tentative location, you have to go on site and you have to see. Okay, first thing is that one. Second thing is that this is in the mine list itself, and then you have to see if you are going into the marine area, how far you will go, because usually you should have one sample from a far off distance also. Okay, so that you can declare that sample as a control sample. Control means area which is completely untouched by a mining activity. Okay, like that you have to see. Now here you can see two maps in which green dots are showing sampling points of February 2016, and red ones are showing sampling points of May 2017. Okay. Now you have seen this one, sample collections. You have seen the preparation of monitoring locations for groundwater, then marine sample. Then what we have to do is that once you know the groundwater levels in that area, after doing the monitoring, you have to draw the groundwater contour maps. Okay, so you can see here that this is my mine list. Okay, this is my mine list, and the yellow line is having RL of 0.5 meter. Blue line is having a reduced level of 1 meter. So of course, the water will always flow from high level to low level, high RL to low RL. So from blue towards yellow. So from even if groundwater will be there, it will move towards seaward side and towards the canal. Okay, towards seaward side and towards the canal. This way, we can see even if any pollution is there, we can declare that it will be going towards the sea and it will be going towards the PS canal, which is passing through here. Now, this was for 2, this is for 2E. Okay. Now, 1 is already over. I have to do some sampling points for 2E. So again, I will design my monitoring network in such a way that it will represent the whole block. Okay, it will represent the whole block. Okay, like that I have to decide. And similarly, once I have taken the sample and I know the groundwater level, I have to draw the groundwater contour map. And this map I'll be plotting using GIS. Okay, I'll be doing interpolation. Of course, interpolation is not covered in this, but since now you know the installation of QGIS, you now know the basics of this. With that basics, you will be very well able to do the interpolation also. Anyway, in a 5-day course, our job is to give you the best maximum possible direction for everything. It is you who has to run the path. Okay, so it's to you who has to walk the path. So like that you can see. Similarly, here also this orange line is 0.5, blue line is 1. So the flow direction will be from higher line to the lower line 1 to 0.5. In this case also the water will be going towards seaward side and also towards the estuary side once there is rainfall or once there is more water in the mine list. Okay. Now once you know all these points, what you can do is that you can decide the location of rainwater harvesting structures also. Okay, and this to be given as a mitigation measures in the same. So of course, this is a standard design. We have taken it from Kinfra. Okay, there will be one filter well in which some coarse gravel and filter sand will be there, and water from roof or land will come in that. And after filtering, it will go to the well. Like that, you can give the groundwater recharging stations. And similarly, we have designed the network for block 4 also. In that case also, we have given marine centric locations. And similarly, we have given groundwater contour maps for that. Okay, I will not go in deep on this. Now you already know the groundwater contour anywhere to be given. Okay, this is for block 4E. Again, groundwater contour maps for block 4E so that you can know where the water will flow and where the water is flowing, the contamination or the pollutant will also flow with that. Okay. Now, one thing you need to understand that when you are working in remote sensing GIS, and especially when you are working in groundwater, what you need to plot is that one intersection of that, and always you have to see whether whether your mining whether your mining will intersect groundwater or not. Okay, you have to see whether your mining will intersect groundwater or not. Now here you see this is beach sand. Okay, and the depth of the mine is at least 4 to 6 meters. Okay, 4 to 6 meters. This is groundwater table. Of course, it will be top high. So when mining is been carried out and groundwater table is only 1 to 2 meter, of course it will intersect. Okay, it will intersect. So when you are mining it, the groundwater will also mix. In that, what will happen is that the heavy metals present in the heavy mineral sand will also mix in the water. Now it is in dormant stage. Water is there, but it is dormant, very slow. But when you move it, there will be turbulence in that and it will mix in the water. So it will impart heavy metals as well as salinity also in the water. So for that, what you have to do is that you have to do simultaneous refilling. Okay, you have to do simultaneous refilling of the sand. Once you have done the excavation, immediately you put the sand so that water will not get the enough time to move into the pit. Okay, then you put the sand, water will be out. Like that you have to do it. And similarly, we have designed one monitoring network for block 3. Also, you can see here these green ones are water sampling location, and this we have superimposed on base map. So again, I am giving you one more idea that monitoring location can be superimposed on base maps also. Okay, similarly, it is fit for block 3, and same for block 3. We have drawn contour maps. Okay, we have drawn contour maps, and this is again a pattern for block 3. This were in two parts. So this is the first upper half. This is the first upper half. The second lower half. Okay. And again, in this case, we have given groundwater recharging station also, as well as we have given some infiltration galleries and simple gravity collection systems also to conserve the water in the area. This is anyway not in our scope, but I just wanted to give you the idea. Okay, here again, that was for groundwater sample and this was marine location. Okay, this was marine location. Now, one more thing is there after this session, I'll be showing you one modeling part of water environment. Okay, because here I have already shown you how we are doing modeling in air, but in the case of a water sample, I only showed you this contour maps as well as some location and also modeling part I'll be showing you after this session. But before that, if you have any doubt, you can ask me. No doubt? Anyone? Okay, then we'll go ahead. Now the part which you are already doing from last 2 days, that is land use land cover analysis, but you would have seen for some area. And now I would show you how, when you are doing EIA, how you have to give it. Okay. So now 20 participants are there. Pratna, are you there? Pratna?
Yes, sir.
Okay. So can you brief me something related to preparation of base maps for EIA using JIS remote sensing? What all points I have shared? I have shared. Pratna? Pratna? You able to hear me? Crystal C, are you there? Grishma KV, are you there?
Sir.
Yeah, so Grishma, can you brief something about the preparation of base maps in EIA? What all points we should keep in mind while preparing base map?
For preparing base map, we should go through which is a study area. Then we should prepare a country map. Then there should be district map. Then we should locate which is road
Okay, okay. And we
and
should also
nearby
give,
water bodies, which all are the
yes.
connectivity
Yes,
sites
yes.
also. We should
Mm.
point out.
Yes. And we should also give any relevant features which may impact our activity. All those things we should plot it in the base map. Okay. Now we will see about the land use land cover analysis. What you have seen in last 2 days where uh, actual carrying out of land use land cover, but now I will show you how to present it when you are doing land use land cover for a EIA. Now here you see this is the false color composite image FCC. I hope you know for this and know this now very well. This is FCC of my study area. Here is block 2 and this is a 10-kilometer radius circle buffer. Okay, this hole is a 10-kilometer buffer. So first what I will do is that I will click my ROI. In this case, my region of interest is this one, and I will plot it first, the raw satellite image of that in terms of FCC, right? False color composites. Okay, then this mining area, which is inside it, this is my core area. This is known as core area, and the outer part is known as buffer area. Okay, it is known as buffer area. So this is my core zone. This is my buffer zone. This you have to keep in mind first thing. Then with the algorithm what Anish has discussed with you, we will be preparing a land use land cover map of SAM. So you have to prepare it properly for the whole region. Here you can see a separate color for inland water body, separate color for Arabian Sea. This is agriculture, mixed vegetation and built up. Okay, you have to give a proper north arrow. You have to give a proper scale bar. Okay, then you have to give the horizontal and vertical latitude longitude grid. Then what you have to do is that you have to give a land use land cover inventory. This is known as land use land cover inventory. First, what you have to do is that you have to calculate the total area. Okay, you have to calculate the total area and you have to say from that total area how much is your built up, how much is your agriculture, how much is mixed vegetation, how much is water bodies, what area of Arabian Sea is has been covering this study area, and you have to find the percentages. Okay, that percentages you have to plot in your map. Okay, plot in a graph. Sorry. So you can see here that the highest area is formed by Arabian Sea, followed by mixed vegetation, followed by built up, then water bodies, and lastly in agriculture. So it will give you an idea as a person who is preparing EIA report, it will give you an idea that what is the area configuration of that area. Okay, what is the area configuration of that area? That's how the land use land cover is to be presented. You can do other things also. You can superimpose some other things on this. You can superimpose the output of air environment on this. Okay, the fugitive dispersal model that you can superimpose. So once you know the land use land cover, many things you can do. Okay, you can do with and without scenarios also in this. Right? So will be other things. Okay. Now similarly, this is a false color composite of 2E Eastern extension. Again, the land use land cover of same, in which we have categorized the land use land cover classes. Similarly, this is for block 4, then block 4 EE. And this is also one of the representation. Like this also you can give. That's why I've included it. Actually, many times they will ask you in a certain format. Okay, and railway roads and all usually we don't give because railway roads and all are a part of built up only. This we give in base map only. But what you can do is that on your land use land cover, you can superimpose railway line, roads and other things also which is there. And you can further classify it as like industrial area, mining area, fallow land, waterlogged area, okay, dried region of water bodies. These things you can only plot once you have visited site at least once. Okay, once you have visited the site at least once, you will be knowing the signatures of that area and then you can do it. Okay. And sometimes you may have to do the land use land cover of that block itself, particular block itself. This is the mine lease area, and then you may have to see how much is available for mining. Now it will have one more significance. One more significance. How that is that if I am carrying out my mining activity here, of course, whatever I'll be clearing out is the mixed vegetation as well as the built up. Okay, mixed vegetation as well as the built up and inland water body. So that means whatever area which is constituted with built up inland water body and mixed vegetation, I can mine and that must send again exit. But at the same time, it will show me that if I'm mining, this much mixed vegetation and built up area will go. Okay, will go means it will be destroyed. Similarly, this is for block 3, land use land cover block 3 in the similar pattern. Now, what I have to do is that the significant components I know now. I know about the base map. I know about the air. I know about the water. And I know about the land use land cover. With these 4-5 things, I can very well give the management plan. Okay. With these 4 things, I can very well give the environmental management plan. So here now one by one we will plot. Now you can see is there, and this is also a response to first this somebody has asked us how we can prepare an environmental management plan. So you can see here that this is block 2. This is KMML block 2. Okay. And I want to give some mitigation measures for the impact which is likely to be done with this. So first thing is that on sea side or on the estuary side, I can give one riprap which is made up of stones. so that the sand will not fall into the TS canal. Okay. Then I can also construct groins. Okay, groins are structure which are used to conserve the sand on the beach. Okay. Then also I can give one sea wall. You can see one blue color sea wall. If I am preparing a sea wall, if I am constructing a sea wall, the high tide line and low tide effect will not cause any effect on this one. Okay, like that. And similarly, when I have provisions for green belt, I can give that also. This green color line is showing green belt, that we have to give one green belt. Okay, this side we have to give one sea wall. You can see a sea wall. There will be road also. Like that, we can give the management plans for a mining lease. Okay, similarly here also, this is for block 2. So we are giving a green belt of 0.297 hectare, which has been worked out with this only, using with this only. And also existing seawall can be strengthened, and we are also recommended to laying out 2 groins. You can see here groin number 1, groin number 2, which will help the area in between this to conserve sand. Now, why remote sensing plays a big important role in this is that once I know my management plan, okay, once I know my management plan, I can work out its length and cost also. You can see here, I have plotted it using GIS, but since it is geo-reference image, I could able to work out its length. It will be around 4.9 kilometers all along the boundary of the mine lease. Then riprap will be around 5 kilometers. Okay, riprap will be of around 5 kilometers. And then there was some area where mangroves can also grow. So we have given that area also where mangroves can come. That is 0.360 hectare. And groundwater recharging wells also we can give here, which we have already shown you the plan. All right, in my previous slides. So you can see here, when you are giving a GIS based management plan, one can clearly see all the things. Okay, one can clearly see all the things which are prevalent in the area. Okay, and at the same time, you can give a proper management plans. Similarly, I can work out the cost also, because I know for 1 meter how much it will cost the plantation of green belt based on the consultation. So I can give a proper cost also. How much it will cost for mangrove, how much it will cost for riprap, how much it will cost for groundwater, and other corporate social responsibility activity, which is not here, not in the purview of this course. Okay. And this is one more example of block 4. Here we have given growing zone on a different thing. You can see here 40 meters, 75 meter, 100 meters, 75 meter. We have given growings on one side. Other side we are giving sea wall and riprap. Similarly, one area we are giving for mangrove plantation. Like that, we can again calculate the area that green belt proposed is 0.086 hectare. Proposed mangrove 5 hectare. 4 number of growings and existing seawall 1.8 km. Like that, we can give. Okay, and again we can calculate the cost. Again we can calculate the cost. And similarly, this is for block 4E. Why I'm showing you all this is this, I want to convey the different types of management plans which can be given. And since it will be there in recording, you can refer it. But as I said earlier, please don't disclose it with other people, because those all these were our private reports. We had a contract with them that we will not disclose the data to any other person, but for education purposes we are showing you. Okay, and this is a management plan for block 3. All this is sent, and we have proposed a full green belt all along the boundary of the block 3. Okay, so up to this point everything is clear. Any doubt in management plan or anything? No one? Okay, if you don't have any doubt, any one of you would like to say something? I told you earlier it will not be a monologue from my side. Anyone? Siddesh, are you there?
Sir, Will you be explaining any case studies related to EIA, like in detail?
So, Siddharth, this is case study only. This is case study, na?
So-
See the title. Tell me. See the title starting EIA of minerals and mining, including cluster of mines and other case studies. One by one, we are seeing all the things in detail, step by step. No, you can explain me like what you were expecting with case study so that I can answer you.
So like this was for mining. Look, I'm saying that are there any other case studies that you can, for example?
No, that is what I'm saying. We have experience in mining of minerals, but the fundamentals
Okay.
and tools and the approach, what I'm showing here, that approach will be same for almost all the sectors, all 40 sectors.
Okay.
There are 40 sectors in here. That is what I'm trying to say. The approach will be same. First, you will make the map. You will identify the sensitive areas. Then you will superimpose, and then you will make the management plan. That is what I was saying.
So this will be same for all the studies.
Yes, the approach will be same. Like same approach you have to go. You have to prepare when suppose you are not doing for minerals and mining. Suppose you are doing for petrochemical complex. Let's say. Okay, it is altogether different project. So in that case also first you should prepare a base map. Then you have to carry out a land use land for analysis, and then you have to wait. Then once you know, 1 second. Then once you know where is what, how much it is, you will plan other things. Like suppose you have to collect water samples. So where my samples will be like that, two from this area, two from this area. Let's say petrochemical complex is in the center of this. Like that only it has to be planned. This is case study only. And in one slide, I am explaining almost 5 different type of project. 2E, 4E in block 3.
Okay. So that was actually my question. Like I was asking, like you said, like what is the approach for different sectors for EIA? So that is what I was asking. It's clear
That is
now.
what I'm saying, Siddesh.
Yeah.
The from remote sensing GIS approach will be same, but the inherent technical content will be different, which has to be seen by the respective domain expert of that time, or in case that
Correct.
will be you. But the approach, what I'm saying, will be same for all. No change.
Okay.
Any EIA report you see, it will start with this only: base map, monitoring locations, land use land cover, modeling, superimposition, then with and without scenario, and mitigation measures and management plan. This is the crux of any EIA.
Okay, sir.
Yeah, I know, I can understand from your viewpoint also, but I believe that if you work on this more, you will understand slowly what I'm saying. Like because it comes from experience also, slowly.
Okay, sir.
Anyone else? Okay, then we'll go ahead with the coastal erosion. So we have seen air, we have seen water environment, we have seen land use land cover and base maps also. Now we will see what we can do for coastal erosion from land use perspective. Okay, so suppose I am taking a base map of a particular site. This is my block 4. Okay, and I want to know this because of this block 4, how much impact of mining on the length or the width of this coastal zone, right? Like how much it is how much accretion and how much erosion has been occurred because of the mining in this block 4. So what we have done is that the width of this block is 0.30 meter and this side 2 kilometer and this side 2 kilometer we have taken. So total length of 4.30 kilometer is there. And from the last end 5 kilometer this side, 5 kilometer on the upside, we have taken one study area. And we are trying to see how much area on coastal zone has been accreted or eroded. Okay, so first this is the base map. As I said earlier, that we have to start with the preparation of base map, and then we will take the false color composite image of same. Okay, so we have taken two images. This is the image of Landsat 5, which is of year 2000, and this is the image of 2019, which is of IRS list 4. Okay, and we are trying to see with this and this how much erosion or accretion has been happened within these 19 years. Okay, from 2000 to 2019. Okay, so first, as you know, we will be starting with the land cover analysis of same. We have seen that how much is the mixed vegetation, how much is the mined out land already, then inland water bodies built up, beach sand and Arabian Sea. Okay, this side. This is for 2000. This is for someone's mic is on, I think. Okay, then this is land use land cover for 2019 and 2000. Okay, so you have two land use land cover now for 2000 and 2019 with a gap of 19 years. Okay, so I hope the objective is clear to you. We want to see the accretion or erosion during this time as a result of mining. Okay, because generally it is said that the impact of mining will be felt 5 kilometer upstream and 5 kilometer downstream. That is the reason we have taken 5 kilometer up this side and 5 kilometer downstream. Okay, of course, this cannot be categorized as upstream, downstream, but it is because it is not a river. But you can say 5 kilometer from the northern part, 5 kilometer from the southernest part. Okay, then we have first seen the shoreline change. So you can see here that this is land. Okay, this is land. So in 2000, shoreline was here. And sometimes it is mixing, sometimes it is overlapping, sometimes it is separate. And this is shoreline for 2019. Okay, this is shoreline for 2019. Now we know that of course some changes are there, and overall there is erosion only, because 2000 it was this side towards seaward side, and in 2019 it is landward side. Okay, 2019 it is landward side. So now we will quantify how it has been done. So the first approach for this is we will divide it in insets. Okay, we will divide it in insets. So we have divided in 1 kilometer by 1 kilometer insets or snippets also you can see. So A, B, C, D, E, F, G, H, I, J, K, L. We have divided it into 1 kilometer by 1 kilometer snippets, and those two shorelines are also there of 2019 and 2000. Okay, now what we will do is that we will zoom in, and inset wise we will see the changes in the area. Like here you can see here accretion is 0 in A. Okay, and erosion is 4.55 hectare. Here maximum width of accretion is 0, minimum width of accretion is 0 because it is 0. But erosion maximum width is 80 and minimum width is 7.23. Here you can see that this is 80, this is 7.23. So this is in the inset A. This is inset A. Similarly, inset B. Here also accretion was 0, but erosion was occurring. So shoreline 2000, shoreline 2019. And this is 1 kilometer by 1 kilometer stretch of that. Here also it seems no accretion, only erosion 74.80, 22.46. Okay. Then of course again see here also accretion is 0. So like that, and also maximum and minimum width you should see, so that you can report in AIA report that how much maximum eroded. Okay, this one and this one, maximum, minimum. Like that for C, D, E, F, G, H, I, J, K, L. Okay, somewhere it was accretion also. Somewhere it was accretion also. And then you can prepare a overall a table of whether it was accretion or erosion. But in this case, overall it was erosion only. So we have lost the sea, we have lost the coastal line into the sea. Okay. So when I'm preparing a report, I can very well say that if I'm carrying out mining in this area, there will be overall erosion. But then there will be one question that erosion can can occur because of this high tide and low tide also, right? Because many places mining is not going on. Still it is getting eroded. Yes, it can happen. But when you are doing mining, mining is enhancing that phenomena. Okay. Erosion anyway, it happens many times. Erosion also happen, accretion also happen. It depends on the littoral drift of the sea as well as the configuration of the land geometry with the sea. Okay, both happens. But when you are doing mining, you are enhancing that phenomenon of erosion that you have to keep in mind. To stop that only, in my previous slide, I have shown you in environmental management plan that we have given groins. Okay, because if you construct groins, there will be accretion of the sand. Okay, there will be accretion of the sand. Okay, so this is how you can also measure coastal erosion. And one more thing, what I want to say is that in this case, we have only covered satellite images of non-monsoon season. Okay, non-monsoon season. Okay, non-monsoon season. But when you are actually doing it in a further detail, you can take different satellite image of high tide and low tide also. Okay, high tide and low tide also. But in this case, we have taken on the same time where water was away from the land so that we can get a clear picture. But if you are doing well, if you are doing in deep where your project requires certain expertise from this only, then you have to do a proper analysis in deep. Okay, approach will be same. RS and GS, Chirag, is it you? No, I wanted to know from last 4 days also who is joining in the name of RS and GIS. Who is this? I'm seeing this from 4 days, but I don't know who is this. Who is RS and GIS? Okay, anyway. So like that, when you are doing for proper land use proper shoreline changes, then you have to go for high tide line and low tide line. Otherwise, with two images of same type of same time when there is low tide, you can very well do the analysis. Okay. Now we will come to the noise environment. So in this case, I will show you a very interesting case study of Nagpur city. And this I did when I was in Niri Nagpur as a research fellow in 2017 and 18. But this work of ours, me and my supervisor, it has changed the course of the noise in the whole country. After this report only, so many policies have been come out, especially the policy related to no honking. Okay, because earlier people used to honk, but we have clearly said in the report that honking has a very adverse health effect on what all people who are traveling nearby the honking zones. So in continuation to my previous slide, noise, not previous slide, my previous talk was yesterday, noise environment. You know now what are decibels, what all other things. Okay. So now I will show you a case study in continuation of that, how you can do noise prediction in a city using GIS modeling using interpolation, and you can work out with a management plan and mitigation measures. Okay. So first thing is that, of course, I told you also already that, one second. I've already told you that any EIS study or any impact assessment study to be started with the base map, right? I already told you. So this is the base map of Nagpur city. Since it was a noise pollution study, I am showing all the minor roads also, because noise, I told you in my slide that the greatest source of noise is 55 to 60% is vehicular traffic. So you can see this is national highway, this is rail, this one is outer ring road, the other one is inner ring road, and then major road, minor road, and city boundary. Okay, this is the base map of the study area, which is Nagpur city in this case. Okay. Then I have to design the monitoring locations. Okay, in earlier slide also I told you. Now you should able to connect it. I told you already that first base map, then whatever components are there, you have to design one monitoring program. If it is water, you have to design like that. If it is air, you have to design like that in a particular location. So in this case, first we have designed the noise pollution monitoring locations. Here you can see that what we have done is that from from the city we have taken 50 samples, 50. Okay, 50 samples. And on each type of entity, be it national highway, state highway, ring road, outer ring road, as well as industrial area, commercial area, residential and silent zone. From all places, we have taken sample. You can see that it is very well distributed, right? You can see very well it is distributed. From national highway also samples are there, state highway also there, major road, minor road are also there, railway also there, and industrial, commercial, residential, silence, all places are there. This I could only do because I know the area and I have GIS tool in my hand. Okay, so I hope it is it is clear to you. First base map, then noise pollution monitoring location design. This is a network how we have designed. Okay. Then we have to carry out the land use land cover analysis of the city. That where is what and how much it is. How much is agriculture. Some ash ponds are also there. Then built up fallow land, industry, scrub land, vegetation, water body. So that when we are preparing noise map, we will be able to say in which area noise is more. Okay, so I hope it is clear to you. Base map, sampling, noise pollution monitoring location map, and land use land cover. Then I told you already that in noise pollution there will be daytime and nighttime. Daytime will be from morning 6 to night 10, that is for 16 hours, and nighttime will be from night 10 to morning 6. That is the whole night, and that is called nighttime, 8 hours. So this is the graph for daytime of working day, and this is night time of working day. Okay, between Monday to Friday. Then there are graphs of daytime non-working day, nighttime non-working day. Okay, these are noise levels in decibels, and these are different matrices. What I have explained you yesterday, I hope you remember. This bar is LEQ, this one is L10, this triangle is L50, L90, Lmax, Lmin. Now you observe that L90 is always there in the bar. Okay, because it is a background noise. This much was always there, but maximum was above that always, right? It is the maximum noise. It will not be there for all the time. So LEQ, L10, L50, L90, Lmax, and L minimum. And similarly, we have this one. This one was working day, night time. This was working day, daytime, night time. Non-working day, daytime, night time. Okay. Then working day, daytime, working day, night time for silent zones. And again working non-working day, daytime, non-working day, night time for silent zone. This was for residential. These two are residential. This is silent zone. Okay. Now comes the main part. How you can predict using GIS and remote sensing. Now you see here, this is a strategic noise map of Nagpur city. Okay, this is strategic noise map of Nagpur city. Especially now you observe here, wherever there is a road, the noise values are high, like 84 to 86 dBA, and this all a road. You can see where I'm drawing the line. These are all roads, and on the road it is highest. But if you go towards the industrial area, like you can see here, Oh, sorry, if you go toward the residential area, noise is less. It is in the range of 64, 66, 58, 60 and all. So with this, when you superimpose it on the land use land cover map, you can very well make the strategy that where are the highest noise and where I should give my attenuation measures. Okay, attenuation measures. Now, one more thing I will tell you in this one. This strategic noise map is important because it will give you the overall picture of the area. Okay, it will give you the overall picture of the area. So this is for daytime, this is for nighttime. Of course, since it is night, it will be more green. Okay, since it is night time, it will be more green. Okay, because in night time noise may not be much. And similarly, for others, this is for working day. This is for non-working day. But we have observed that in non-working day and working day, not much changes are there. Only slight variation. Okay, so this is how you can use GIS in carrying out noise pollution monitoring and then plotting it strategically. In this case, we have used linear interpolation model for prediction. Okay, I hope you remember that in my one of the slide, I told you that there will be some mathematical model for prediction. There will be some empirical model for prediction. In this case, we have followed linear interpolation model of GIS in this. It is there in QGIS also. Okay, you can do Kriging also. ARIGING, Kriging. Okay, this also you can do for interpolation. And this is night time. This is last time's participants. Anyway, we'll take one photograph like this. So with this, I end my case study part. It is not over now, but I have given you a significant amount of information, like how I have applied remote sensing in GIS in various AIA projects. And now if you go and read in other AIA report, if you download various types of AIA report, you will see that similar approach has been done. It will start with base map, then it will come to the land use net cover, then there will be monitoring location design, be it air, be it water, be it soil, be it noise, be it coastal erosion, anything. And then finally, they will apply some mathematical model in it and they will do the impact prediction. Also, I have also shared with you
पांच
how
नमाजों में से सिर्फ 3 कर दी, फजर और इशा को खत्म कर दिया, रात को हलाल कर दिया, ख्वाहिशी की चीजों को भी हलाल कर दिया और रमजान के रोजों को भी खत्म कर दिया। जब लोगों ने देखा कि
So sorry to interrupt you. Can you once again repeat that noise pollution?
you are saying something, Ajay?
Yes, sir. Yes, sir. Actually, can you repeat once again? Actually, I'm not feeling well, sir. So that's why I can't able to continue the class.
I'm not able to hear you, Ajay. What did you say?
Sir, I'm not feeling well, sir. That's why I can't able to continue the class, sir. So can you repeat once again the process of how did you extract the noise pollution by using the that vector data as well as raster data, and you are getting the dB values different range. Once again, it will be very useful for me.
Oh, yeah, sure. No, what we can do is that I'll be putting the recording now. There you can see.
And if you don't mind, if you have that practice data, if you have some PDF, we will do that steps. If you can just saying it's okay, but if you have any steps or protocol, we will do and we will do by you. It will be our homework. We will do and we will give tomorrow like that. It will be good for us.
No, PDF I can share. I'll be sharing you the PDF of this presentations. Whether
And
that will be enough
also,
for you?
if it is if we have a data set, it will be very useful for us. Like we
No,
will do.
no. What you can do is that as far as data set is concerned, you can generate random data in Excel for your learning purpose. Okay. You can open your Excel, MS Excel, and you can generate random data for data analysis.
Okay.
And then you can carry out these things. PDF anyway, I'll be sharing with you.
Sure.
Because I am giving you recordings, that's why I'm not sharing the PDF so that you can watch. PDF I'll share with you, no problem.
If I understand, but the steps how you are doing it will be very at the end of the class. What are the things actually you are teaching in land use land cover? Just like special how you are doing the classification right now. We are doing with noise. If
when you are end of the class, if there is any notes like our process of doing the classification, process of doing noise pollution analysis, if there is any notes, it will be very useful.
Yes, yes, we'll be giving you, and whatever maximum papers or anything are there, we will share with you. But one thing you keep in mind, Ajay,
Yes,
that this course na already we are trying to give you lot of information
Yeah,
in
sir.
short time. So what you have to do is that no, it is not like that. It is our duty to teach you. As a CSR scientist, it is my duty to spread maximum knowledge with minimum cost to the people. But what I expect from you is that you have to keep doing from your side.
Yes,
So
sir.
that then you will understand more. We'll share with you some papers, some papers in which step by step some things are given, recordings and PDFs. All things will share with you, but you all keep in mind that recordings will be there only for 1 month. Afterwards, I'll be taking it down from YouTube. Before that, you can download it. Okay, you can use any YouTube downloader and you can download it for you in next 1 month.
Sure.
So if you'll share PDF or PPT, that will remain for us forever, no? For long term.
PDF I'll share. PDF I'll share. But the thing is that when I speak something or any speaker speaks something, now they will share a lot of other information also, which you may not get in PDF. So it will be
Sir,
good if you recording.
Actually, this topic is entirely new for me.
Hmm.
I'm getting theoretical part, but I have not worked upon this. Means I don't know about its applicability.
But by now you should have known, like it is a fourth day. Lot of things are
Yes.
shown already.
Yes, sir, but I'm facing issues in doing these things.
Okay. No issue. That's okay. Recordings are there that you watch. PDF will share with you. A single PDF document will share. There is no doubt in that. I already said on the group, PDF will be shared with you.
Okay,
But
sir,
I
thank
want
you.
you all to watch the recordings first. That's why I'm
Well,
not sharing. That's why I'm
okay.
not sharing any documentation with you by now. Because what happens now, we try to if your documentation is there, we are not interested in putting more efforts in seeing recording. So it will be good if you can watch it. If you can watch it, then we'll say, yeah.
Say once again how you are doing the noise pollution.
What?
Can you repeat the topic? Like how did you do?
Yeah, sure. Anyway, I will just show you once more time. Noise pollution, no?
Yes, sir.
Okay. So one thing is clear, na, that we start with the preparation of base maps, right, Ajay? Once again, I think you are not able to see my screen, no? Oh, sorry. Yeah, sorry. My bad. Now, one thing is clear that whenever we start any AI study, we start by with the preparation of base map. Okay. Right. So I'll show you one more time. I'll just brief you this noise environment, impact of traffic on noise environment, case study of Nagpur city. So what we have done is that first we have start preparing a base map. Okay. First we have start preparing the base map, and then we have plotted all the roads. Okay, we have plotted all the roads because the majority of the noise will be from road. And then, as I said earlier, the next step in any EIA is to design a monitoring plan. Because where I will monitor, what I will monitor, that I have to plan. And I have to plan in such a way that it is a representative sample. Okay, it is a representative sample. So here you can see is that I have taken sample from national highway also, state highway also, major roads also, minor roads also, railways, industrial and commercial, residential, silent zone. And I have taken sample in such a way that all these entities are represented properly. Okay. Then up to this one, it is clear.
Yes, sir.
No, I am
Yes, sir.
always asking Ajay Prakash also because he
Sir,
wanted us to.
And
Hmm.
how you are measuring the noise level by using any instrument? Like
Are you asking about instrumentation?
No, sir. No, sir. Actually, you are setting the monitoring points on a different places like highways, state highways, major roads.
Huh.
Like it's a continuous monitoring. Like you will fix the machine, or it will be you have already have data. And then
No,
you
no,
will
no, no. We have done the monitoring by going on to site for 48 hours. A machine was at the same place for 48 hours. And
So
the
you have this much,
supervisors,
so you have this much machines, like you have collected so many data.
we don't have this much machine. We had only 10 machine. So what we have done is that we have covered it in 4 weeks.
Okay.
Okay, so like initially we have covered 10 location, then other 10, then other 10, and like that. Because 50 machines at a one shot, it will not be possible to put.
Okay, sir. Okay, sir.
Yeah, that is what. And then, no, but I want to understand from you, what do you want to ask when you are saying how I measure the noise? Whether you are asking for instrumentation or you are asking for GIS mapping or what?
Sir, actually, it's a right now you are doing it's a survey, ground survey, by using the different noise level at the different platform. It's right.
Yes, not platform, different language and your class.
Yes, different class.
Hmm.
So it's going to directly mark the DP values, like how much DP value reached and how much
Yes.
low DP value,
Yes, yeah, decibels.
decibels.
Yeah.
So how this up to this point I can able to understand how you are doing. So you can
No,
do
that is what I said now.
yes.
That is what I'm coming on. That using instrumentation, we measure the noise, and using GIS, we have decided these locations. Okay, and on this location, with the instrumentation, we have measured the noise
So
for
what will be
working
the
day.
range, sir? What will be the range of that hearing? Like how much the spatial distance? Like if the
How
machine
much
is
the?
fixed, what is the surrounding area? Like if the machine is fixed in the particular place, for example, national highways, it's an NH something. So how much area it will cover? I'm not
No,
asking.
no. That is what I'm saying. You have to recall my first lecture on noise environment. It is not about the surroundings.
Okay.
It is about the whatever coming from the out, what is recorded on the sensor of that noise. And as far as surrounding is concerned, you will expect houses in residential area, right? You will expect hospitals and institutions and high courts or other kind of things in silent zone. In industrial area, you will expect industries, right?
Yes, sir. Yes, sir.
And commercial, you will expect commercial complexes. So it is like that.
Yes, sir. I can able to visualize.
Yeah. You can read here this point. It is self-explanatory, no? And then of course I told you that land use land cover is the prime importance for any EIA study because we should know where is what and how much it is. And these two maps can be superimposed over each other to know how the noise is varying. And finally, we have prepared this graph for residential areas.
How did you prepare this?
What?
How did you prepare this guy?
Ajay, it is very basic in Excel. So I
Okay.
think it will be
Yeah,
good
yeah,
if we
I got
can limit
Yes,
to
yes,
the.
sir. I got it, sir. Actually, I thought
I think
Yes,
it will
sir.
be good if we can limit to the fundamental part. Rest you have to do. You try to do it.
Yes, sir. Yes, sir.
Yeah. Okay. So this we have prepared using MS Excel, of course, in which working day, daytime, nighttime, non-working day, daytime, nighttime, and similarly for silent zone, both working day, nighttime, working day, daytime. And finally, I told you, as I told you earlier, we have applied interpolation, linear interpolation in that, and we have, based on this location, we have prepared the strategic noise map. And as usual, since the traffic will be more at road, highest noise is on the road, and lower pitches of noise in the residential area. Like that, we have prepared, and we can take this map and superimpose it on this land use land cover map.
Actually,
So
you are
that we can
doing layering.
Hello?
Right? You are doing the layering, right?
Ajay?
Sir, I am saying the correct answer. Like right now, you have the base map. Next, you have interpolation. Third, you have LULC map, right?
Yes.
So you are going to fuse all the things and you are getting the output, or it is a separate part. That part
No,
only.
no, no, it is not separate part. It is collectively we have to arrive at a conclusion. Okay, it is collective. Like first I know that these are the base map,
Okay.
where are roads, and okay, then based on the roads, I have decided my sampling location and I went with the instrumentation. I measured the noise. Then I have my land use land cover with me, so I know where are the residential areas, where are the vegetation, where are other things. And based on this, I have created one strategic noise map.
Mhm.
So it is like collectively all only I'll be able to do. With single thing I will not be able to do, because unless base map is there,
Okay.
if this map is not there, I'll not be able to make this map. Right? This is the boundary. So it is the collective effect of all.
Yes, sir. Yes, sir. I can able to understand.
Okay.
Sir, like right now you are, if there is any data like 10 years data or 20 years data already is there, any websites are providing right now?
Any
Related to-
data related to noise?
Yes, sir. Yes, sir.
No, actually there are two ways to do it, and this I am saying to all. There are a lot of AIA reports which are already in the public domain. Either you can take data from that. One thing. Second thing, there is one MS Excel tool in which you can randomly generate the data for your work for doing analysis. Like I take a lot of students for MSc, MTech and other thing. So many times if data is not there, we will generate the data in Excel, because here our purpose is learning. All right. So in both ways you can do it. If you search EIA.pdf on Google, you will get almost 50,000 to 60,000 entries in which data set of all these things, air, water, soil, noise, all these things will be there. From there you can take the data. Ajay?
Sir, yes, sir. I'm getting all the things.
Hmm.
What you are saying.
Yeah. Same thing only we have to do for all.
Oh yeah, it's a day and night, right? Okay.
Yeah, daytime, nighttime, then again daytime, nighttime. This is for working day, daytime, nighttime. This is non-working day, daytime, nighttime. It is like that.
Yes, sir.
So, any other clarification, other doubt?
Sir,
PDF I'll
Like-
share today. Yeah. Siddesh.
sir, when before you started the topic, you said that when you collected that data and then when you submitted that data, you came up with some policies. So, sir,
Yes.
so can you tell something about that?
Yes.
Like how?
Yes. That work we did for MPCB, Maharashtra Pollution Control Board.
Like, so like what
So
were the
you-
what were the measures taken? Like after you published the data, what were the measures taken to
Yes.
reduce the pollution?
No, first thing is that there was a declaration of no honking zones in Maharashtra. If you go to Maharashtra local newspapers in last 5 to 10 years, you will everywhere see that based on the NIRI report, this area was declared as no honking zones. I mean, you cannot go and honk there. That was the first measure. Second measure, what we have observed is that uh, High Court is there, hospital is there, nearby residential area is there, and at the same time there is one industry also. So what we have suggested in our report that pollution control board should take measures to give permission to such industries and any other activity in a residential area. That is also one of the prominent outcome of that. And third one is, everyone knows that because of this high court case only, this was a high court case actually, that someone has put on the pollution control board and the report comes to us. Now there is a significant level of awareness towards noise pollution and honking as compared to previous era when the report was not prepared. So these are the three major outcome of the report.
Okay. And so one more question I had. So
Mhm.
when we are and report is EI report is being made for a large scale what do you say projects, for example, refineries or anything. So what is the minimum duration that report takes to complete? Like how
Okay.
many
So first
months
thing is
or
that, I got your point. So first thing is that uh, EIA EIA reports are prepared based on the quantum of the work, quantum or the capacity of the project. So if it is a large scale project and the quantity is more, the minimum duration recommended is 1 year. Okay, all 3 seasons has to be taken in account while preparing the EIA report. But if it is a small project, only one season non-monsoon data will be sufficient to prepare the EIA report.
okay, sir, got it.
Sir, any
Sir, I
models
had posted a
to,
question.
You have posted something?
Yes, sir. Should I repeat it or you can
Sir, should
go
we
through?
include the airports and satellite launch sites if any in the points of sample collection for broader points? Yeah, actually, airports are already there, but you must be aware that all the airports will be at the outer part of the city. The planning itself is like that. So mostly the initial 2-3 kilometers of that airport will be, there will not be much development, and they are categorized as no development zones. Okay, still airport noise will be there. That aircraft noise and other things will be there. But in purview of whole traffic, it is not that annoying. That's why there is not much heat on that. And satellite launch also, actually,
Okay, sir.
satellite launching stations also are like the sites are decided very far from the normal residential area. So even you see this many things we know that Chandrayaan launch are there, other satellite launches are there. We don't come to know about that based on the noise. Only we come to know when it is published in news. So it is not to be accounted separately. That's what I'm trying to say.
sir,
Okay, sir.
as you were teaching in a previous class, like in air pollution, you have models like how to do the models like Cashier, like that. For the noise pollution, there is any models?
Yes, yes. For noise pollution, there are a lot of models, and in fact,
Don't mind, can you
uh,
show some 5 models? It will be useful for us.
1 minute, 1 minute. In fact, I have my paper itself. One. Let me just. I can show you now, and I'll share that also. It is author's copy. It is in an international journal, but you all can use it for your own purposes. Just, just 1 minute. Yeah, I will share with you now. This is authored by Shravant. I was the corresponding author for that. Just 1 minute. I'll share my screen and I'll show you. That is my work only. And You are seeing my screens now?
Sir, yes, sir.
Yes, sir.
Yeah, just 1 minute.
Yes,
Just
sir.
getting. Yeah, so this paper we have published, I'll share it with you, but keep in mind that if you go on site, you have to pay some 39 euros. So you just don't share like this, just because you are in course, I'll be sharing with you. But you keep it with you only, all the resources what I'm sharing. So in that, all the comprehensive list of the models we use in noise pollution is given. Okay, so you are able to see my screen now? Anyone?
Yes, sir.
Yes, sir.
Yeah, so you can see here the title of this
Visible.
paper is Noise Pollution Assessment and Management in Rare Earth Mining Area, a case study of problem. So Shravant and me, and along with one of our students, authored this. I am the corresponding author in this one. So we have given all the things like which how much is generated by all, and it is in a international journal of high reputation. It's called Environmental Monitoring and Assessment. So you can see that, and this is the I showed you, right? We have to start with base map, then monitoring, right? I showed you same steps I shown you all. This is the way only which will go, and these are the models. You can see first one, octave band analysis, ANN modeling, and we have given the formula also. You can see the formula in between.
Sir, actually,
you can see
ANN you just use with machine learning, right?
what?
ANN, like
ANN?
you are just using machine learning, and then you just come up with the result, or you have any separate applications? Like for example,
No, no. First thing you need to understand, Ajay, is that there are two types of interaction between us. One is that which is focused on what I'm saying. Other one which you supposed to work out and do. So
okay,
my request to you will be is that you ask which is in the purview of the course, and other things which you can work out that you have to work out. Right?
sure,
Because I can very well answer you any n number of things, but I want to focus my energy and time on what what this course intended for. Okay.
sure.
So you see to it, you work out. That is your job. You have to do it. My job was to give you the direction as well as maximum resources possible, which I'm giving already. Now you work out that, whether it is simply done or whether that you do.
Yes, sir.
So I will share the research paper with you all. There you can get some more details of it. Interpolation. How this is which one? I mean? Interpolation, how to do? What is it? Yeah, this interpolation actually it will be there in QGIS itself. Okay, when you are opening the QGIS, there will be a command in which you can choose what interpolation model you have to use, and with that you can do the interpolation. What is NP in graph? NP is simply the noise pollution. It is the sample ID. NP denotes sample ID. Okay, and third one I have already answered. So I think we'll stop now, and we'll meet at We'll meet at 3:45. One more short response session will be there. Then that will be the end of the fourth day, and other things will be discussed tomorrow. Okay, and tomorrow my request to you all will be that it will be good if you can join with your video camera open, so that we can have some 2-3 screenshots, because we are not able to do it physically, and usually we post all these things on social media. So that will be good if you all can join with your video camera on initially tomorrow. Okay, and tomorrow one esteemed speaker from outside will also be joining with us. He will show you the direct application of remote sensing in water quality measurement. How this interaction of near infrared band and all these things are used to work out water quality of a particular water body. Yes. So okay, then we'll meet at 3:45.